Hello everyone. In this lesson we're going to look at classifying reactions into different types. Now we're going to do that by looking at how the products are different than the reactants. So we know in a reaction old bonds break and new bonds form, and that changes one kind of thing into another kind of thing. So we're going to look at how the products are different than the reactants. We're also going to look at the number of things involved, and that's going to help us classify these different kinds of reactions. Now there's 5 different kinds of reactions: synthesis and decomposition. These two are opposites of each other. So synthesis brings things together and forms a more complex compound, and decomposition breaks things apart and usually forms a less complex compound and 2 or more substances. And then we have replacement reactions. In replacement reactions we have things switching places, so substances switch places. And then we have combustion, which is reaction with oxygen. And this is exactly what it sounds like. Combustion means fire, and we need oxygen for fire. So in a combustion reaction, we're going to react some kind of fuel with oxygen. So let's take a little bit closer look at each one of these. Synthesis, like I said, means to bring together, so 2 or more substances. And when I say substance, that could be an element, but it could also be a compound. Both of those are substances. So 2 or more substances combine into a single compound. Example of this would be if we take oxygen and react it with hydrogen, and we make water. Now this is not balanced because I don't have the same number of atoms on both sides. I could balance it by placing 2's here. But that's a synthesis reaction. 2 elements come together, form a single compound. So we take 1 and 1 and make 1. And remember, when we do a chemical equation, the reactants, so A reacts with B to produce, that arrow is written red as to produce or yields this compound AB. And then the decomposition reaction undoes a synthesis reaction, breaks things down, so we're going to have a compound broken apart into 2 or more different substances. So hydrogen peroxide, which is H2O2, will actually decompose, and it breaks down into water and oxygen gas. So we started with one substance, this compound, and we ended with 2 substances, a compound and an element. Now remember, oxygen gas is O2 because oxygen is part of Brinkelhoff. That's bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. And these are the elements that, if they're alone, come in pairs. So if they're a single element, they're actually diatomic. So each one of these, if they're written in the chemical equation, they won't actually just be a single, they'll be a double. And then we have the single replacement reaction, which is exactly what it sounds like. One element replaces another element in a compound. It generally involves one element and a compound. So we're going to have some substance that's usually an element A that will react with a compound that's got 2 parts, and generally speaking, the A kicks the B out and comes over here. So A replaced B, that's one replacement. Classic example of this maybe would be if we took sodium chloride and reacted it with magnesium, we could get magnesium chloride, MgCl2, and sodium. So I wrote this a little bit out of order compared to that, but I can still see I have an element and a compound, and I end with an element and a compound, but where sodium used to be paired with chlorine, now magnesium is paired with chlorine. And I would actually need 2 of these and 2 of these to balance that reaction. But that's a single replacement reaction. One metal replaced another metal in a reaction. And a lot of times you'll see that. You'll either see a metal replacing another metal, sometimes you'll see hydrogen replacing a metal, depends on the reaction. But generally speaking, if you see a compound and an element reacting and you end with a compound and an element, you can probably think single replacement and then just check to see if one element got replaced, and if it did, it's a single replacement reaction. Then there's a double replacement reaction, and this is going to be 2 compounds, and you're going to end with 2 compounds, but the 2 compounds will be different. So we could take lead 2 iodide, and we could react it with potassium nitrate, and we might get out of that lead nitrate and potassium iodide. So here we had lead with iodine, and now we have lead with nitrate. So that means we had a replacement. Here we had potassium with nitrate, and here we have potassium with iodine. So we had another replacement. The lead took the place of potassium, and the potassium took the place of lead. They switched partners. So two compounds switch partners. We end with two different compounds. That's a double replacement reaction. And then there's combustion. And like I said, this is fire, so we need fuel and we need oxygen. And that gets us combustion. So we generally get carbon dioxide and water. If we react something with oxygen, it's a combustion reaction. You can also look to see that we get carbon dioxide and water, but we don't always get those things. We do if we're burning something like, say, propane. C3H8 reacts with oxygen, O2, and that oxygen breaks these bonds and then new bonds form, and the carbon reacts and forms bonds with the oxygen, and the hydrogen reacts and forms bond with oxygen, and we get these two different compounds out of that. And if we wanted to balance this, well, we might look at that and go, okay, well, we need 3 carbons for our 3 carbons and 8 hydrogens for our 8 hydrogens, and then we have 10 oxygens. We need lots of oxygen for this reaction to occur. But what we see is some compound reacts with oxygen, and that's combustion. Now, metals can also combust. We don't generally think of this, but we could take magnesium and light it on fire. And if we light magnesium on fire, we'll get magnesium oxide. So magnesium reacts with oxygen, and out of that, we get magnesium oxide. And this is a single element and a single element reacting to produce a compound. So you can also look at this and see that it is a synthesis reaction, but it qualifies as combustion because it does react with oxygen.